This is section 8.5, probability distribution and expected value. So let's first talk about what a probability distribution is. And to do that, we need to first decide about a random variable. And that's a function that assigns a real number to each outcome of an experiment. A table that's going to take those possible values of a random variable together with the corresponding probabilities is called a probability distribution. The sum of the probabilities in that distribution must always equal 1, and that could be a little varied if you are rounding numbers. So let's look at what that might look like. So give the probability distribution for the number of heads showing when 2 coins are tossed. So if we let x represent the random variable number of heads, then x can take on the value 0, 1, or 2. Now think about it. This is our sample space if we throw 2 coins. We're either going to get 2 heads, a heads and a tail and heads, or tail, tail. So looking at that way, if you're going to have 0 heads, then you have a 1 out of 4 probability. If you're going to have 1 head, you've got 2 out of 4, because if you're going to only have 1 head, it's this guy and this guy. So that's 2 out of 4, or 1/2. And for 2 heads, again, we only have 1 out of 4. So that's listed in that. And then also, that's the distribution in a table format. But this is a histogram showing the same thing. Number of heads along here, and the probability this way, so we can see the 1/4, the 1/2, the 1/4. So you could sometimes see it in that. All right. And this is if we were using the binomial probability to figure it out when we do that. Okay? We did that in the last section. The expected value, suppose the variable x can take on the n values, and you have x1, x2, x3, etc. And suppose the probabilities that occur are p1, p2, p3, etc., all the way to p sub n. Then the expected value is you multiply the random variable times the probability for each of them, and then you add those together. That gives you the expected value. Okay? So for binomial probability, the expected value is n times p. The expected number of successes is the number of trials times the probability of success in each trial. All right, so I think that gives us some language to think about. Let's look at the problems. For the experiment described below, let x determine a random variable and use your knowledge of probability to prepare a probability distribution. So this is a little bit longer for this one question, but it's not too bad. 3 balls are drawn with replacement from a bag that contains 2 orange balls and 4 black balls. So how many do we have total? We have 6 total. The number of black balls is counted. So we want to get the probability distribution. So we're talking about black. How many black are in there? 4. So the probability that you're going to draw a black is 4 out of 6. That's 2/3. So 2/3 is our P. That's our probability. So we have to do this. We're going to draw 3 balls, and we have to do 1 each for 0, 1, 2, 3. So as you can see, I've done combination of 3 taking 0 at a time, and then your probability goes here. 0 is your exponent from the formula, and then 1 minus 2/3 raised to the 3 minus 0 power. And you end up with, sorry, that got down there. You end up with 0.0337, and it's going to tell you to round to 4 places. So 0.0370. Then if you do it for 1, that changes to 0.2222. If you do it for 2, we get to 0.4444. and for 3, 0.2963 if we're rounding. So those numbers would be going in these boxes. And so we've created that distribution. The other ones that we're going to work on, that's created for us, and we're going to work on the expected value. Remember that the expected value is the random variable times the probability. So 2 times 0.2 plus 3 times 0.4, etc. And then you add those up and we get 3.5, which would be our answer here. Same thing in number 3. Find the expected value for the random variable. And we're going to multiply 9 times this, 12 times this, add all of that up, and we get 14.46. Number 4, find the expected value for the random variable whose probability function graph is displayed here. So they didn't give us the table, they gave us a histogram. So we needed to create this, and we had 1, 2, 3, 4, and 5. And at 1 we're at 0.3, at 2 we're at 0.25, at 3 we're at 0.1, and we go down the line like that. We create our table, and then to get our expected value we can multiply 1 times this, 2 times here, do that all the way down, add them, we get 2.7. It says round to the hundredths, so if there's not another digit we will add a 0. Number 5, again we have a histogram. We need to create our distribution table, x and p of x. So we've got 10 and 0.05, 20 and 1.5, and so we go through and we choose those and create that table, and then you can do your expected value. Remember, it's your x times p of x. And do that all the way down, add those, you get 30. And I think that's all we have. We just have those 5 questions to give you a taste of doing that with the distribution, and that should do that for 8-5.